Hi, today we are discussing direct variation. We're in our red book, page 140 even, and we're looking at numbers 4 through 28. We determine direct variation using two criteria. Number one, we use the equation. If our terms can be written in direct variation and it's in y equals kx form, then we say yes, it's a direct variation. If we can graph the coordinates and it's a straight line and passes through the origin 0, 0, then we say yes, it's a direct variation. So let's get started. We're starting with number 4. Number 4, we want to determine if it's a straight line and if it has the origin 0, 0, because we have a set of coordinates, okay? So let's take a look. We can just read off our x's to determine if it's in a straight line. -1, 0, 1, 2, that's a straight line. Let's check out our y. -1, 0, 1, 2, that's a straight line. So we have a straight line. Now, do we have the origin? If we take a look and we say, yes, we do. Origin 0, 0. So therefore, it is a yes. It is a direct variation. Let's look at number 6. On number 6, we want to determine, do we have a straight line? We have 1, 1, 1, 1. Well, that's straight, all ones. And then we have a 2, 4, 6, 8. But I wonder what that looks like. Let's take a look. If we have 1, 2, and then 1, 4, 1, 2, 1, 4, and then 1, 6, and then 1, 8. When we connect, yes, we have a straight line, but it does not go through the origin. So since it does not go through the origin, then this will be a no. Okay? Let's take a look at number 8. On number 8, let's see if we have a straight line. All right? When we read off our numbers, 1, 2, 3, 4, that's straight. 2, 4, 6, 8, that's straight. Well, let's see if it goes through the origin. Well, here we have 1, 2, we have 2, 4, we have 3, 6, we have 4, 8. Well, here we connect our dots, but to be sure we're going through the origin, let's finish the rest of our line, okay? Let's get our slope. Our slope is, our rise is 1, 2, and our run is 1. So our slope is 2 over 1. So to finish this line, let's fall and go to the left because it's positive. We fall 1, 2, and we left 1, and we discover, yep, it goes right through the origin. So this is a yes. Okay? Let's look at number 10. Number 10, do we have a straight line? -1, 0, 1, 2. Yes. Here, -2, -1, 0, 1. Yes. But look at our origin. When y is 0, x is 1. And when x is 0, y is -1. So in a case like this, we do not have a 0, 0, but we do see the 0. So we know that they do not go through the origin. So this is a no. Here for numbers 14 through 21, we will use our formula to determine if it's direct variation. Here we use the graph to determine direct variation. Well, let's use our formula. Keeping in mind that we want to isolate y. So if we isolate y in this case, instead of subtracting x, the inverse would be to add the x to both sides. And therefore, our formula would read y is equal to 4 plus x. Does this match y equals kx? The answer is no. So number 14, the answer will be no. It is not a direct variation form. The equation does not have a direct variation form. So let's take on number 16. We want to isolate y again. Instead of adding 3, the inverse would be to subtract 3. And so y would be equal to x plus 3. Does that have a direct variation form, y equals kx? And the answer is no, it does not. cannot be written in direct variation form. All right, let's look at number 18. In number 18, we want to isolate y. So first we're going to remove the x. Instead of adding it, we're going to subtract it, so that negative y is equal to negative x. Then we cannot leave y as a negative, so we're going to divide by -1, divide by -1, and therefore y will be equal to x. All right, that's number 18. So the question is, can this be written in direct variation form? Well, technically, what we have here in front of the x is a what? A 1, right? So then, in this case, is it 0? No, k does not equal 0. K equals 1. So if that is the case, then on number 18, our answer is yes, it is in direct variation form. All right, let's take a look at number 20. Well, once again, we want to isolate y. So instead of multiplying x to the y, we're going to divide both sides by x, and therefore 8x is equal to y. Is it in direct variation form? In this case, for number 20, the answer would be a no. Okay, now we're moving on to the next page. On the next page, we have number 22. It's written, and they tell us there is an error here. The student indicated that this was a direct variation because it made a straight line, okay? But this person, or this student, forgot the other criteria of the straight line, that it must go through the origin. Did it go through the origin? No. So that's the error that they made. Yes, it's a straight line, but it did not go through the origin. So the error is, did not go through origin, which is 0, 0. Okay? All right. So now let's take a look. If we have a y and if we have an x, we can write the y and x in direct variation form as indicated. They're telling us that these are direct variations, and they want us to write the direct variation form y equals kx. Okay? So what we do, we first take the formula y equals kx, we plug in y, we plug in x, and we solve for k. Once we have k, then we rewrite the formula in direct variation form. Y equals, and whatever the value k is, and then x. Let's take a look. First, y equals kx. Plug in the y, which is 4, equal to k, which is x is 2. Isolate k, dividing both sides by 2, and we discover 2 is equal to k. So this should be written as y is equal to 2x. That will be direct variation form. Let's take a look at number 26. Number 26, remember the original formula, y equals kx. So therefore, our y is 60, our x is 15. Okay? We divide both sides by 15. All right? And 60 divided by 15 is 4, is equal to our k. And therefore, our formula should be written y is equal to 4x. On number 28, we have y equals kx. Therefore, x is 20. Y is 20. X is 12. Okay? Divide both sides by 12. And k is equal to, in this case for number 28, we have 20 over 12. We're going to simplify it, dividing both sides by 4. Okay? And therefore, can you see that? Yes. And you see that? We're going to find out that this is going to be 5 over 3 is equal to k. So our formula is written y is equal to 5/3 k. Right? That's our lesson for direct variation. Hopefully you understand a little better about direct variation. If you have any questions, Give me a call. Bye.